So welcome to another Syvecs help video, and this video today is based on the new 765 S7, S8 and S12 firmware release. Now this firmware release carries a huge number of advantages and loads of updates, so it's really important that we go over those and explain how a lot of these functions work, predominantly focusing on the new cruise control updates, because these are going to be a big factor for many of our owners and dealers. So currently I have got a 711 firmware release open. I've chosen this one because generally I think that most people will probably be around this level, or most likely at 752, which was a release that is on the forum as well, and there's also 761. So obviously the later the firmware version you've got, the more easier it is to integrate the newer firmware. So what I'm going to do is I'm going to go back to a really old one, 711, and focus on these changes. Now there is another video which is on how to update the firmware, so I'm not going to go over that in this video, but on our Syvecs forum, in the dedicated ECU area, whether S7, S8 or S12, there are the options there to download the latest firmware, and in those links it does explain what is new and what is changed from previous versions. So let's dive in and get this Golf R calibration updated. So the old cruise control basically was a RPM based logic which had a speed tuning on top. The new software will have the ability to basically have it just purely dedicated on speed tuning, with the ability now to resume, set your speed, your wish speed, and also have the cruise control active during gear shifts. So first step, with your old calibration offline, make sure you have the latest SCAL version, which again can be found in our forum. So you want these 2.17.11 or above, depending on when you're watching this video. And what we're going to do is we're going to update this firmware version. So we're offline, we're going to go cal, change software version. I'm just going to use the hotkeys most of the time. And then S7, 700, 765. Now what it will do in doing this is it will basically look at all the differences between the existing maps that are present and the new ones that did not import. So what we're going to do is basically we're going to tag this, and it will basically mark in the calibration all the new updates. So I'm going to quickly run through these. If you want to get to the cruise control section, then you can just skip forward to that bookmarker in this video. But it's important to go through these because a lot of people will probably look at these changes and be like, what's all these new things? So wastegate control, you've got the ability to select between two target map selects now. There's massive updates to the pit limiter, which are actually described on the forum for those bits. And then there's updates to the override. So what I'm going to actually focus on is on the important stuff that's going to potentially be a benefit to you or going to cause problems when you're upgrading. So in the run mode fueling, we've done updates to the overrun fuel cut. So basically you've now got the ability, well I think it was in the 711, but to select the activation load, whether it's pedal position or TPS. So you've now got an ability to have an entry delay, so you can have it so that when the closed PPS or TPS is being set, it doesn't initially do the overrun fuel cut until you've got that time passed. And you've also got a drive-by-wire limit now, so if you wanted to, you could really jam shut the throttle as well to have a softer type of overrun. Wastegate control, like I said, you've got the ability for two different target maps, and you've also got the ability to target based on the post pressure instead of the actual manifold pressure, so the pressure before the throttle body. Then you've got a drive-by-wire limiting function where you can again limit based on the PTP, which is the post throttle pressure. And then there's updates to gear cut with the barrel position. It will start, number of dog kicks allowed, gear blip changes. That was the one based on the live barrel position. But the ones that are really important and really need your attention, idle control. So the idle learn now has got a drive ratio error learn. Probably a good value to set that out would be like say 100. And then you've got the learn rate now. It's not marked, but the learn rate can actually go lower than the minimum value. I would actually suggest setting that probably somewhere around about the 0.008% a second. And then you've got the ability to do the idle duty learn sweep. What that means is, if for example in the current, if you press the help and it describes it, if it's learning, say, this column here, what it will do is, if you're basically requiring more idle duty here in this section here, it will automatically sweep up and apply that as a whole column, so that during starting and stuff like that. Now, some people don't like that. They just want it to have a learn in the area where you're currently in. And if that is the case, then just turn this map off. In the limiters section, this would need some attention as well. You've got a control delay now, so basically you can allow it to overshoot on the manifold pressure target limit for a certain amount of time, say 50 milliseconds. You allow it just to, if your boost control just ever so slightly spikes above the limit, then you can have a delay time on there. One thing that's going to really need to make sure of when you are updating this is that the drive-by-wire target limit range multiplier now is based on the gear and the engine speed. Before, it was just based on the gear. We found it very beneficial to have it based on your engine speed rev limiter target. So that's not the actual RPM, that's your rev limit RPM, because at different RPM limit points at very low load, you might need a lower kind of range in your drive-by-wire limitation for the rev limiter to get it to kick in nicely and become smooth. So this map will get defaulted to 1. Really important, what you can do is you can open up your previous map of that, which will show it as a row of just where it was the gear, and then you can copy those values in and then copy them in below as well, and then just go select all and math interpolate Y, and it will basically put those back in. If your map is viewing in this format when you initially update, you can press the next to the M button and the question mark, you've got the where the comma and the full stop, those buttons there allow you to spin the map around, and then that makes it quite easy to copy in when you're going from say a single axis map to a 3D. What else we got in here? You've got the ability now for the drive-by-wire target limitation to be based on your RPM average DT, so the rate of change of the RPM as an average. This is quite useful, so you can have your your control loop here is affected by the rate of increase of RPM as well. And you've got the ability to disable it during gear blip. So what else is really important? Supercharger bypass stuff. There's nothing really in there that's going to cause big problems when you're updating. There's a maximum position sensor fault. Right, this is important. Your inlet base duty now and the exhaust base duty will be basically 0. Now, the reason for this is because you've now got the ability, we've made it from a single axis to now a 3D with the temperature, and you can actually change what that is. So at the moment it's based on oil temp. If you go to VC, you can actually change that here to be based on the axis that you want. So oil pressure and oil temp, you can change those to whatever you like. So that's quite useful. What that means is this value will be 0. So a good little trick that you can do here is you just do a pace cal load of your old calibration, and what it will do is it will show you at the top here the difference. So you can see here it's minus 43 in the top left. So what you could do is just go math, select all, and then go math, or just set actually 43. And that was the value it was in there before, okay? And the same then applies for the exhaust duty. You can see that was 46, so put that there, and then that will line up to exactly how it was before, and your VVT will work as it did. So let's close that. Right, cruise control we're going to come back to because that's a massive update, and I'm going to do that later in this video. Output functions, you've now got a second closed loop PWM. The fan now has the ability to be a frequency instead of just an on-off for fan 1, 2, 4 and 5. Fuel pump, you've got the ability to have now a second PWM fuel per output and an output duty linearization. This is really useful because you can set your priming duty, your off duty and that for the second pump, And then you can have your duty linearization, which is based on your fuel pump control demand, to basically linearize when each pump kicks in, which is really really useful. What else have we got? Tacho output has got the ability now to indicate the engine speed on the dash if you've got an old PWM wire. And then there's loads of different bits up to here. I mean, these are not important. They're not going to cause your software to not work after updating. You've got more configurable maps now, and you've also got the ability to trigger when the map turns on, the CM map, and so you can go over those. And in the pin assignments, anything that's undefined now, you basically need to set that to not connected or assign it. The cruise control stuff will all go to undefined. So at this point, let's jump into the cruise control. So the cruise switches now, as you can see, are basically all set as undefined. And in the previous firmware, that would actually just be one cruise control switch. And that would just basically be normally your on button, which we would used to before just trigger the cruise control to engage when it saw that request of that button. But now you've got the ability to have up to 6 buttons to basically have all the different states of a cruise control system. Set, resume, on, off, suspend, etc. So in this particular car, this is done as an in-range setup. So one pin has got a resistive diode chain, resistor chain, and basically with a pull-up with different buttons, the resistance value through the pull-up changes, and hence your voltage output is different. So we're going to go over that, but you can, if you have got multiple buttons, say 6 different separate buttons on 6 separate inputs, you can use those as well. So what I'm going to do is jump over to a live calibration. But before I do that, there is one more thing that I've just thought about that is really important when you do the firmware update to the latest version. Any of the frame contents, basically down here, the cruise state needs to be set there. And in here, the cruise target, probably best to change that to wish. So on the dash, it will show you your targeted wish speed as you're changing it before even moving. Under the RS232, you'll see that anything that's been set as not set, you need to set that up. Now that used to be cruise state, so put that back to cruise state. And under the generic CAN transmit, if you had cruise switch in there before, cruise active, that would be set to not set, and that will need to be changed to either spare or cruise state as well. So let's jump into now a live calibration when we're connected in a car and actually see then what is going on with these positions and these buttons. So what I'm going to do is show you how I've actually assigned these buttons all to the same pin. Pin sharing is available on the cruise state switches, and my on-off button I've got to a separate switch because it's a latch button, not a momentary. So right, first thing, let's go to the cruise switches and go over this. So if you've got it on a resistive diode, like resistor, I keep saying diode, but it's not, resistive resistor chain, or you've got it as a slave input that's being used that is defining all the different CAN stages of the cruise switch, then if you've got it on a physical input, then you need to most likely turn the pull-up on. If you haven't got it on a physical input, it's on a slave input, then don't worry about it. The polarity, just leave it active high. If you have got it on an on-off switch for the different states, then you can set the polarity to suit. And the validation time, 100 milliseconds generally suffices. If you want the buttons to be reacting a little bit quicker, then drop that time down. So what I'm going to do now, I'm going to open up a gauge for the input that I've got all the switch states on here. Make that a bit bigger. And what you'll see now is as I'm changing the lever, you can see lots of different voltages are coming out. Now, I would suggest that you set up your buttons to be like this. So on, off, set, resume, up, down, and cancel. If you don't have all of these buttons, and for example, the up is shared with the set, like that, and the resume is with the down, then you can do that as well in the mapping, and I'll go over that in a moment. So what I'm going to do, as I just spoke about, the low voltage threshold for A doesn't matter because it's a physical switch. B is the set button. So as I press and hold the set button, you can see it go to 2.2. So I set my low threshold at 2.1 and my high at 2.3. Then for the up, or the resume should I say, pull that back, you can see that goes to 3.1. So once you've set up all these low and high thresholds for each of the different states, you need to program the ECU by going device program. It will then come back online, and then if you double click on these cruise switch states over here on the right, when you press the different buttons now, you should see the different states turn to off and on, etc. Now these buttons, once they're set up and reading correctly, what we then need to do is set up the button mapping. And this is done at the top under cruise control. You first of all want to enable it. We don't have to have that enabled actually, to be honest with you, initially, but I've just got it enabled here. It might moan at you when you enable that you haven't got an off position set. So at which point you probably just disable that and then set up the switches first and then re-enable it. Cruise control principle. So basically, if you've got a rally car or something that you don't have a vehicle speed, that you can just do it based on how it was before with RPM. If you have got a good vehicle speed signal, then for a manual transmission, select manual. For an automatic, select auto. This car is an auto DSG, so I've selected auto. Now in here, what I'm going to do is I'm going to set these all back to their default here, and then go over these positions with you. So switch A is the on-off switch. So if you're in the off state and you then turn it to on, then that switch state will go to on. And if you're in the on and active and you then change the state to off, then you set off. If you're in the on state for the next one, which is the set, so you can see when I press the set button, the cruise B at the bottom changes. If you're in the on stage or active, then this becomes set. Now, if that button is shared, as I spoke about a minute ago, like the set is sometimes shared with the down button, then when the cruise control is active, you would do that. So the set when the cruise state is just on, i.e. the lever is on, but it's not active on the cruise control, then that is the set button, and then the active is there, and then the same might be for the other one where you've got the resume and up is shared. Then you can define these positions in here to suit. Okay, for me, I have 6 individual buttons, so I'm just going to set these like this, then up, down, down. Now the cancel button, which is an F for me, I like to have that if it's in the on position, then it cancels it, which clears the wish speed, and if it's active, then it suspends. What that means is that your wish cruise control speed wish will basically get reset when you, if you're in the on state. So if I just program that now. So if I just now bump up my speed target wish by moving the cruise lever up, you'll see the wish state changing. If I now, it was active and I press the cancel, then it would keep that wish state where it is. But if it's in the on position and I press the cancel stage, then what you can do is actually have it cancel your target back to 0. So sorry, I should be looking at the target. That will reset that back on there. So now you've got your buttons mapped and everything set up as you wish. Let's dive deep into the settings. Now, just to recap, if you have got a physical on-off button, then you would set up your on to off functions in this mode. So where I actually have a physical on-off switch with the on-off cruise control logic. So as you can see, I set that to off and then turn it back on. Then I have it basically mapped out in here. But if it's just the in-range momentary switches, then you would just use the top one. Vehicle speed nudge is self-explanatory. As you basically bump up your speed, if I just change my cruise control gauges now, as I bump up the speed, the wish target you can see there is jumping, and you can change that into bigger steps if you want to 5, like so. But 1 is generally is pretty good. So the enable conditions, the pedal position stability. So basically what this is as default this is 5. I generally like 10%. This is how much the pedal can move around when you're engaging cruise. Most OEM cars are about 10%. Engine speed stability, so basically if the engine speed is jumping around loads, then the cruise control won't engage unless it's stable within a fraction of 0.1. You can open that up to 0.2 if you've got quite particularly jumpy RPM, and the same with the speed. The disable conditions, these are the same as they were before. So you've got a minimum engine speed per gear. Well, that wasn't per gear before, but now it is. So you've got a minimum engine speed, maximum engine speed, minimum vehicle speed, maximum speed per gear, minimum gear allowed, steering angle, G's, wheel spin, brake pressure to disable the cruise control, and then you've got the drive ratio error limit. So what the basically is that you can press the F1 help on this and it will describe it more for you. But basically when you're driving around, you've got a drive ratio that should be set up correctly for your car. If it's not, and it's worth checking this, what I would suggest to do, down here on the bottom right, you've got drive ratio VS. You can get to that as well by going to drive ratio and then selecting VS. What you want to do is drive around when you're in each gear, look at that value and make sure that it is similar to what you've got in here, or check the error, the drive ratio VS error, percentage and error, to make sure that is very small. If it's large, like above, say, like a couple percent, like 3 or 4%, then you need to come into this table here and adjust your drive ratios based on each gear, based on the value which is in that drive ratio VS. You punch all that in, device program it, and then that will update it. And then what the inner one is when you're driving around and it's in an actual gear, locked in a gear, it will allow a drive ratio error limit of up to 10%. This is for cars that have got maybe a torque converter or something like that, or a slipping clutch. It allows it to have an error limit for 1.5 seconds. The outer is for when it's changing gear. So after it's changed gear and it's basically going to have quite a change in your drive ratio, when it does that, it allows for up to 25% error for 0.7 seconds. If you've got quite a slow changing gearbox, then you could increase that time if needs be. And the recovery time is how quickly it allows the error to recover. Torque control tolerance time. What that is if any torque control items kick in when you do like a TRQ fuel sev. If any of these torque kick in, if it's active for more than 1.7 seconds, then it will disable the cruise control. And in F1 you can see those torque values that would cause that. Maximum driver pedal input. So when the cruise control is active, if the pedal was to be moved more than 5%, it will disable. And it's got an option here to cruise trip goes to suspend instead of off if there is a trip. So let's say, for example, you're driving along, cruise control active, you need to suddenly slow down by pressing the brake and it disables the cruise control. It will go into the suspend state where it will save the wish as it was before, and then when you press the resume button, the cruise control will naturally go back and speed up to that target where you were before. In here, the vehicle speed tuning, you've got your vehicle speed error fraction, you've got a progression rate. So this is how fast the target can progress and change based on your wish. So say you've got a wish at the moment of 59, my current speed is 40. It will basically allow you to set a progression rate of how quickly that changes. And per second, you can see here, only allows you to increase your target up to your wish at 5 kilometers per second. You've then got your proportional and integral control. The values in here as default are pretty good. So what you've got the maps, the axes are based on is you've got your vehicle speed error and your cruise vehicle speed move. So if your speed is increasing to get to your target, then the move value will then become positive. And same with the integral, you've got the same thing as their speed error and the cruise vehicle speed DT. Like I said, most of these you pretty much should need to look at and leave them alone. But if you do find that you're not, I've got good control, or basically it's a bit lazy, then you can increase your proportional and integral to suit. Engine speed control is exactly the same as it was before in the previous cruise control. Then you've got a pedal adjustment gain. Basically what that means is in some of the higher gears where you've got more load being applied, you need a bit more a pedal adjustment gain to be able to get to your targets, to stop the integral having to work so hard. So this is what this map is for. And then you've got a maximum pedal target integral that's allowed and a maximum final pedal target. So these are pretty much all the maps that you should need, and hopefully at this point you're still with me and it makes sense. So what I'm going to do now is go for a drive. You can see some of these values working and see how it actually works on the dash as well. And hopefully get it set up with your car. So I'm just going to now just turn the cruise control. I'm just going to turn it off for the minute because it was already on. So I'm now going to turn the cruise control system on by pressing the button to turn it on. And you can see it displays a speed target now. Now what I can actually do now is I can use the buttons to be able to set my target speed before we even start moving. We can also then cancel that, and the cancel button on this particular car is still for the cal override. But if you actually turn off the cruise control system again, so you see the cruise control system turns off, then when you press the up and down button, it still works before, as if when you were changing calibration switches. But if you turn the cruise control on, that doesn't work, and it now changes the speed target. So when you're driving, you can either already set your target speed that you wish you want, or you can just drive up to the current target that you want and press the set button. So I'm going to illustrate that now driving along so you can see what I'm talking about. So as I now pull away, press the resume button, it will now accelerate to the target speed which I've set at 63, and when it gets there it will slowly slow down the control logic and hold that target speed. I'm just going down a hill slightly and you can see it's working very well to control that speed.